It's strong enough to build skyscrapers, yet it can shatter in an instant. It holds the hottest liquids, but it's born from ordinary sand. You're surrounded by it right now, in your pocket, looking out a window, in your hand. But you've probably never seen it for what it truly is. It's a material with a secret. Its atoms are trapped in a state of beautiful chaos, like a liquid that's been frozen in time. This is the hidden story of glass and how it quietly built our modern world. Our story starts not with a window, but with a bead. Over 4,500 years ago in Mesopotamia, ancient artisans likely stumbled upon the first true glass by accident. They weren't trying to see through it, they were trying to imitate precious jewels. Early glass was a luxury, an opaque, colorful substance treated like lapis lazuli or turquoise. Archaeological evidence shows that the very first glass objects were beads, likely created as a byproduct of glazing pottery or working with metals. But making it wasn't as simple as just melting sand. The process was a delicate dance of chemistry. Artisans learned to mix silica sand with an alkali like soda ash to lower its melting point and a stabilizer like lime to make it durable. They'd heat this mixture, then painstakingly press or carve the opaque material into small treasured objects. From Mesopotamia, this knowledge found its way to Egypt, where glass-making truly flourished. Egyptian artisans perfected a technique of wrapping molten glass around a clay core to create exquisite perfume bottles and vases. For thousands of years, glass remained rare, a symbol of power and wealth on par with gold. It was beautiful, solid, an object to be looked at, not through. And for a long time, that's how it stayed, until a single puff of air changed everything. Around 50 BC, a revolutionary invention appeared along the Syro-Palestinian coast that would forever change our relationship with this material: glass blowing. Roman craftsmen discovered that a gob of molten glass could be gathered on a hollow pipe and inflated like a bubble. That single discovery was a game changer. Glass production, once a painfully slow process for the rich, was suddenly fast, cheap, and versatile. The Romans turned a jewel into an everyday commodity. But why does that work? The secret lies in the wonderfully weird atomic nature of glass. When you melt the ingredients, it becomes a thick, honey-like substance. As it cools, the atoms don't line up into a neat, orderly crystal structure. Instead, they get locked in a completely random, jumbled arrangement. It's the chaotic structure of a liquid, but frozen solid. Scientists call this an amorphous solid. This unique state allows a glassblower to work their magic. The cooling glass stays pliable enough to be shaped, yet it's sturdy enough to hold its form.
The Romans mastered this, creating everything from drinking cups and storage jars to the first crude window panes for important buildings. An industry was born, spreading across the Roman Empire and laying the foundation for the world of glass we know today. When the Roman Empire fell, that glassmaking knowledge was scattered. But by the 13th century, a new capital of glass emerged on a small Venetian island, Murano. The Venetian government ordered all glassmakers to move there, partly to protect the city from fire, but mostly to guard their valuable trade secrets. And they were serious. If a Murano glassmaker shared techniques with an outsider, it could be considered treason, punishable by death. For centuries, Murano's artisans were the undisputed masters. They created glass with unbelievable clarity and complexity. But their most dazzling secret was color. They learned that mixing specific metal oxides into the molten glass could create a brilliant, permanent palette. This was chemistry as high art. Cobalt oxide produced deep blues. A tiny pinch of gold chloride created a stunning ruby red. Manganese resulted in a beautiful violet. They also developed mind-bending techniques like mille fiori, or 1,000 flowers, which involved fusing colorful glass rods to create intricate patterns. The glassmakers of Murano weren't just craftsmen, they were alchemists, turning sand and metal into breathtaking art that was the envy of the world. For all its beauty, glass remained a handcrafted luxury. But the Industrial Revolution cared about speed, consistency, and massive scale. The world suddenly needed millions of identical bottles, endless jars, and huge flat sheets of glass for the windows of its growing cities. The artistry of Murano couldn't keep up. The first big leap was the automatic bottle-making machine in the early 1900s, which could churn out bottles faster than any team of humans. But the biggest breakthrough came in the 1950s from the British company Pilkington. Until then, making large flat window glass was an expensive process of casting, grinding, and polishing. The solution they devised, the float glass process, is brilliant in its simplicity. Molten glass flows from a furnace directly onto a shallow bath of molten tin. Since the glass is lighter, it floats on top, spreading out under its own weight into a perfectly flat, uniform ribbon. This ribbon is then slowly pulled across the tin and gradually cooled. Finally, it passes through a long oven in a process called annealing, where it's cooled at a controlled rate to relieve internal stress and prevent cracking. This process, still the standard today, made flawless, cheap, flat glass a reality, paving the way for the glass-walled skyscrapers that define modern architecture. We've gone from beads to bottles to buildings. But in the modern era, we've demanded something new from glass. We've asked it to be impossibly strong.
The secret to making glass strong lies in stress, perfectly demonstrated by Prince Rupert's drop. It's a tadpole-shaped piece of glass made by dripping molten glass into ice-cold water. The water flash cools the outside into a solid shell while the inside remains molten. As that inner core finally cools, it pulls on the rigid outer layer, creating immense compression on the surface. This makes the head of the drop so strong that you can hit it with a hammer. But all that tension is stored inside. If you snip the fragile tail, you release that energy, and the entire thing explodes into dust. This is the exact principle behind the tempered glass in your car's side windows or shower door. The glass is heated and then rapidly cooled, creating that same high compression surface. That's why it's so tough, and why it shatters into small, relatively harmless cubes. But the champion of glass strength is likely in your pocket. Your smartphone screen is a masterpiece of material science, strengthened not with heat, but with chemistry. In a process called ion exchange, the glass is dunked into a hot salt bath. Smaller sodium ions on the glass surface swap places with larger potassium ions from the bath. These bigger potassium ions are crammed into the spaces left by the smaller ones, creating an incredibly dense, compressed surface layer that's ridiculously resistant to scratches and cracks. Of course, this journey from sand to smartphone isn't without a cost. Glass manufacturing is an energy-hungry process, with furnaces burning fossil fuels to stay at extreme temperatures. But here, glass reveals another secret. It's almost infinitely recyclable. Unlike plastic, glass can be melted and reformed into new glass over and over with virtually no loss of quality. Using recycled glass, known as cullet, to make new products reduces the need for raw materials and can lower the furnace's energy demand by up to 30%. Every ton of glass recycled saves over a ton of natural resources and keeps a significant amount of carbon dioxide out of the atmosphere. This makes glass a key player in a circular economy, where one product's end is just the beginning of another's. So take a look around. That window, that drinking glass, that screen in your hand, it's not just some simple object. It's a direct link to ancient Mesopotamian artisans, secretive Venetian masters, Roman ingenuity, and Industrial Revolution engineering. It's a material of paradoxes, a solid that acts like a liquid, fragile yet incredibly strong, born from the earth and endlessly reborn through recycling. The next time you swipe your screen or look out at the world, remember the thousands of years of art and science it took to create that perfect, invisible barrier. You're not just looking through a piece of glass, you're looking through history. If you enjoyed uncovering the hidden story behind this everyday material, subscribe for more stories about everyday things. Thanks.